We want to show that 2x squared minus 7x plus a half equals 0 can be rearranged to give x equals 1/8 times x times 2x plus 1 plus 1/16. Let's start with the original equation. So we have 2x squared minus 7x plus a half equals 0. If we add 8x to both sides, we get 2x squared plus x minus 7x plus 8x is 1x plus a half equals 8x. Let's just write this the other way round. So 8x is 2x squared plus x plus a half. We can factorize these two terms. So 8x is common factor of x, open bracket, 2x plus 1, and we still have the plus half on the end. Note here, the x times 2x plus 1 gives us the 2x squared plus x. If we now multiply both sides by 1/8, 1/8 times 8x is just x. 1/8 of this is 1/8 times x times 2x plus 1, and then 1/8 times a half is plus 1/16. We now want to show that 2x squared minus 7x plus a half equals 0 has a root between 3 and 4. So we have f of x is 2x squared minus 7x plus a half. We need to evaluate f of 3. This gives us 2 times 3 squared. Take away 7 times 3 plus a half. This is 18. Take away 21, which is minus 3, plus a half, so it's minus 2.5. Evaluating f of 4, we get 2 times 4 squared, take away 7 times 4, plus a half. This is 2/16, which is 32. Take away 28, which is 4. Add a half, which is 4.5. So we have a change of sign, which, as we know, implies a root. So there's a root in the interval 3, 4. We now want to use the iteration formula. xn plus 1 is 1/8 times xn times 2xn plus 1 plus 1/16 to find the root between 3 and 4, correct to one decimal place. We're going to take x0 equal to 3. Let's set this up on the calculator as normal. So we want to put into the calculator 3, since this is x0, and equals. This sets 3 to the last answer. We can then set up our formula. 1/8 is 0.125. We want to multiply that by the last answer. Then multiply that by open bracket 2 times the last answer plus 1. And then add 1/16 or 0.0625 at the end. If we calculate this, we get 2.6875, and we note that this is not between 3 and 4. But let's carry on. We've had x0 is 3, x1 is 2.6875. You should then find that pressing equals again gives that x2 is 2.204 and so on. If you continue, you'll find that x10 is 0.072 and so on. This value is nowhere near the interval 3 to 4, where we know we have a root. Let's investigate further. We know our function f of x is 2x squared minus 7x plus a half. If we evaluate f of 0, we get a half. If we evaluate f of 1, we get 2. Take away 7 plus a half, which is minus 4.5. This change of sign implies that we have a root between 0 and 1. So our iteration has taken us to this root, the root between 0 and 1, despite the fact that we started with x0 equals 3, very close to the root between 3 and 4. So far, over the 3 examples, we've seen 2 different arrangements of the same equation, which gave us different roots. We've also seen with this one that starting it near the root between 3 and 4 took us away and found a completely different root. We're going to examine the behavior of this technique over the next few examples. Some of this will be beyond your syllabus, but it is worth watching these examples, and I suggest that you do this in order to see some of the pitfalls of this method.